Okay, I want to give you a second about inverse functions. So, the first thing you should know about an inverse function is this picture with bubbles. Because that's the first thing we should know about functions.
There's two bubbles.
So, which way does a function go?
It usually goes from the bubble left to bubble right.
Yeah, so usually I do this, right? Like, I write f takes stuff over here to stuff over there.
Yeah.
Okay, now, a few days ago we talked about the difference between evaluating and solving, right?
So that would be
evaluating is
doing the function.
just doing the regular function.
that way, right?
Yeah.
Going that way.
Yeah.
So for a regular function, you can kind of think evaluate, right?
Yeah.
Okay, now, if you're given a y and you want to find the x that goes with it, right? You're given an output, you want to find the input. What's that called?
Solve.
That's called solving, right? So that's this thing, which you use an inverse function for, and I'm dotting this. You guys have all seen the notation, f to the little minus 1.
It's not the negative 1 power.
And it's not the negative 1 power. This is a special thing that does inverses.
Mm-hmm.
You should be careful, because you guys know trig functions, right?
Yeah, like
Eh?
arc sine as opposed
Okay.
to the sine to the negative 1 power.
Yeah, so I want to draw this difference. Sine of x to the negative 1
No.
versus sine inverse of x.
You're not inversing the rule, you're just inversing the entire.
You guys see that?
Yes.
So this is a negative 1 power because it's on the whole name of the function of x.
Yeah.
And this is an inverse function because the negative 1 is just on the name of the function itself. You guys cool with that?
Uh-huh.
Does that help that thing from trig class that was confusing?
It wasn't good.
Maybe? No? Okay. None of you were confused? Good. Okay. So this is the solve direction. Why do I have a dotted arrow and not a solid arrow?
Because you want to differentiate between.
Because there are different ways to go about doing that.
Not all of them work.
Yeah, the formula will be different. Totally fine with
You can
that.
get multiple
I'm okay with
answers.
that. I'm okay with the idea that they take different variables even, right? That like normally this is an x and this is a y, so why don't I write f inverse of y all the time? Right, I should really write f inverse of y because it should take y's. But I write f inverse of x all the time. I'm okay with that issue. The thing I'm not okay with is, does this arrow always work?
Right.
Is this thing always a function?
No.
No, in fact, I already tricked you. What did I say in the last 2.5 minutes?
Inverse
That was a
functions.
lie.
Inverse functions.
It's f inverse x and y. It's over there. That is something we should remember from trig class.
That is something you should remember from trig class. Sine does not have an inverse. This sine inverse function is a partial inverse. In the same way that x squared doesn't have an inverse.
Oh yeah, because if you inverse it.
Why doesn't x squared have an inverse function?
Because the parabol's like this, and the tail's the vertical like this.
Oh, because it has both sides already. Because it's a
So if I told you that, say, x squared was 4,
because the negative answers are the same as the positive answers.
right? You would get 2 or
Negative 2.
negative 2. So the idea of solving x squared equals a number does not have a unique answer.
Right, which is right for plus or minus.
You guys see that? The plus or minus in there is telling you that it doesn't have an inverse function. So solving is a little bit more complicated than just getting an inverse function. If you have an inverse function, solving's easy because you just hit it. Right? Then it becomes an evaluate.
Yeah.
Sometimes there isn't an inverse function for a good reason. You guys cool with that? So for that, I need a test. I would like to know when is there an inverse function.
When it's a 1-to-1 ratio of answer.
So when is f of x invertible?
When it's input, output 1-to-1.
Yeah. Answer. Sorry, question started with when, answer starts with when as well. So when f of x is 1-to-1, what do the ones mean in this?
Input and output. For
Well,
one input, you only ever get only one output.
super close.
For every one output, you only ever get one input. I see.
Yeah. So what that means, so the definition of a function, right, is that each input is associated to one and only one output.
Yeah.
This is backwards.
Right.
This is saying, and also each output is associated to one and only one input.
Fair enough.
You guys see that?
Yeah.
And the way to check that is this thing called the horizontal line test.
Yes.
You guys, what's the vertical line test? How do you
It's a
phrase that?
function.
Yeah, that tests whether something's a function, right?
Functionality versus invertibility.
Yeah. So if you run across a vertical line, what are you looking for? You're looking for
Repeating in the x values.
You're looking for anywhere it hits more than once, and it's not a function if it hits more than once, right? So horizontal line test is the same thing. If any horizontal line intersects the graph of f of x at more than one point, f is not invertible.
Fair.
The other way is also true, meaning if any horizontal line intersects only once, then the function is invertible.
What's the no?
You guys cool with that? That's a little harder to demonstrate. This is a really obvious, like, if you can draw a line across and it hits more than once, you don't need to bother trying to find an inverse. You guys see that?
But you can't find a partial inverse.
But you can sometimes find a partial inverse depending on how nice the function is. So the square root is a partial inverse. Sine inverse is a partial inverse. How about tangent inverse?
Tangent inverse.
What's
Oh,
tangent look
that's
like?
perfect.
You guys remember?
No, you can't, that's invertible. Definitely invertible.
Tangent's definitely invertible.
Right? You can't. What? It's got tons of asymptotes.
Remember, it looks like this, right?
Oh, JK.
Yeah. if you
So
invert that,
horizontal line hits
Yeah. There and there.
twice. So yeah, tangent inverse is also a partial inverse. Why do we even write them?
Yeah.
Because you want to solve so bad, you need a part, like, and they're predictable, right? Like, this spot here, the spot I would get out of doing tangent inverse, and this spot here differ by a multiple of pi.
Okay.
So as long as I can find one answer using the tangent inverse function, I can just add pi to it a bunch of times.
Okay.
You guys cool with this? Okay, good.